some of the details of using the sinusoidal wave equation now. So one question we might ask, well, how do we tell which direction the wave is travelling from the sinusoidal wave equation? It turns out that the signs in front of the x and the t terms in the equation tell us which direction the wave is going. So when we have the equation y as a function of x and t is equal to a sine kx minus omega t plus phi, this describes a wave travelling in the positive direction. Whereas when we have the equation y of x and t is equal to a sine kx plus omega t plus phi, this describes a wave travelling in the negative direction. So the rule is, when the signs in front of the x and the t terms are opposite, the wave is going in the positive direction. When the signs are the same, the wave is going in the negative direction. Another thing we might ask is, well, how can we use this equation to calculate the speed of the wave? We've seen before that the wave speed, v, is equal to f lambda. Now, we can multiply the top and the bottom of this equation by 2 pi and end up with the same thing. So we can say that v is equal to 2 pi f times lambda divided by 2 pi. And we'd want to do this because now we can relate it to the wave number and omega. So we know that the wave number is equal to 2 pi over lambda, and this tells us that we can write 1 over k is equal to lambda over 2 pi, which is what we had in our equation for speed. So our equation for speed, we can replace the 2 pi f with omega and the lambda over 2 pi with k. So we can get the speed of the wave as omega on k. So let's have a look at an example of using this now.
So the question is, what is the speed of a wave described by the equation y of x and t is equal to 2 sine of 3x plus 2t plus 1? Is it going in a positive or negative direction? Okay, so to answer this, we'll need to use our equation v is equal to omega over k. Now, omega in this case is what's in front of the t. So omega is equal to 2, and that's in radians per second. And k, that's what's in front of the x. So that's equal to 3, and that's radians per meter. So now, substituting in, we've got 2 radians per second over 3 radians per meter. So you can see that's going to be 2/3 or 0.67 meters per second as the speed. Now ask us if it's going in the positive or the negative direction. In this case, the term in front of the x and the term in front of the t have the same sign. So this tells us that it's going in the negative direction.